Hello there and welcome to your next math lesson. Please open up your math notebook, turn to the next available page, and at the top of that page write simplest form. Simplest form. Now, simplest form has to do with fractions. Now, first of all, what does simplest form mean? The best way to explain what simplest form means is to show you with an illustration, one that you're all familiar with, probably eating pizza. Let's say you had a pizza that was cut in 8 slices. Okay, this pizza is cut in 8 slices, and let's say you're really hungry. So by yourself, you eat this slice. Then you're still hungry, so you eat this slice next. You're still hungry, so you eat this slice. You're still hungry, so you eat this slice. After that, you're full. And then you want to know what fraction of the pizza do I have left? Well, when we write a fraction, the denominator goes on bottom and it represents the whole. So the total number of pieces before you started eating, that's the denominator. And there were 1, 2, 3, 4, 5, 6, 7, 8 slices. So the denominator would be 8. And then the numerator is the part, and it represents how much you have left. So you have 1, 2, 3, 4 pieces left. So you could say you have 4/8 of the pizza left. But notice there's another way you could write this fraction. You could think of the pizza as split into 8 pieces, and you could say I have 4 out of the 8 pieces left. But you could also think of this pizza as cut into 2 pieces. The piece you have left and the piece you ate. And you can split it evenly in 2 as well. And if you do that, then there's 2 pieces total, and you have one of those big giant pieces left. Now, these fractions both name the same value. They're equivalent fractions. They mean the same thing. But 1/2 is in simplest form and 4/8 isn't. So what does simplest form really mean? It means you make the numerator and denominator as small as you possibly can while still having this fraction represent the same amount. And why does 1/2 represent the same amount as 4/8? Here's why. Because 4 is exactly half of 8 and 1 is exactly half of 2. So they represent the same amount. And you can see that they represent the same amount because you can split this pizza into 2 very big pieces, and then you'd have 1 out of 2 slices. Or if you think of it as split into 8 slices, you have 4 out of 8. Same amount either way. This just means bigger slices, less larger slices, and this means more smaller slices. Let's do another example like that. Let's say you had a pizza cut into 6 slices. Okay, a 6-slice pizza. And let's say you eat this piece, you eat this piece, you eat this piece, and you eat this piece. You're really hungry. And you want to know what you have left. Well, how many total slices of the pizza were there? 1, 2, 3, 4, 5, 6. So that's the denominator. How many pieces do you have left? 1, 2. That's your numerator. But notice there's another way you could split up this pizza too. You could think of every 2 slices as 1 slice. So this could be 1 slice. This could be 1 slice, and this could be 1 slice. If you split it up like that, then there's 1, 2, 3 total slices, and you have 1 of them left. And you can see that 2/6 and 1/3 are equivalent fractions. They mean the same thing. The difference is 1/3 is in simplest form, whereas 2/6 isn't. Because in 1/3, we've made the numerator and denominator as small as they can possibly be. That means we've cut the pizza in as few slices as possible to make it represent the same amount as 2/6. And you can see that they represent the same amount because it would take 3 2s to make 6, and it would take 3 1s to make 3. So this numerator, 2, takes up the same amount of space out of 6, this denominator, as this numerator, 1, takes up out of this denominator, 3. 1 takes up the same amount of 3 as 2 takes up of 6. Now, there's 2 questions that we want to answer in today's lesson. How, aside from drawing pictures, which is not the easiest way, how do you put a number, how do you put a fraction in simplest form? And how do you tell when a fraction is already in simplest form? Those are the 2 questions we're answering in today's lesson. Again, how do you put a fraction in simplest form? And how do you tell when a fraction is already in simplest form? Let's start with an easy one, like 4/6. Here are the steps to putting a fraction in simplest form. Why don't we box this off and write those steps starting right here. Step 1 is find the GCF for the numerator and denominator. So remember that, oops, you can't even see it that well because my face is in the way. Find the GCF for the numerator and denominator. Remember, GCF stands for greatest common factor. So that's the biggest number that's common, that's a factor that's common for both 4 and 6. The biggest number that 4 and 6 have in common as a factor. The biggest number that's a factor for both 4 and 6. Now, we learned in yesterday's lesson, there's 2 different ways we can find the greatest common factor for 4 and 6. The first way is we can just list all the factors for 4 and 6 and then pick the biggest number that's in both lists. So we could list 1, 2, and 4 for 4. Those are the 3 factors of 4. Those are the only factors of 4. Because 1 times 4 is 4 and 2 times 2 is 4. Nothing else can be multiplied together to equal 4. The factors of 2 are 1, 2, 3, and 6. Those are all the factors of 6. Those are the only numbers that can be multiplied together to equal 6. 1 times 6 is 6, and 2 times 3 is 6. Nothing else equals 6. So we're looking for the GCF, or the greatest, that means biggest, common factor. The word common means both lists have it in common, or it's in both lists. The biggest number is 6, but that's not in this list. Then we have 4, but that's not in this list. 3 is one of the larger numbers, but it's not in this list. The biggest number that's in both lists is 2. So we just did step 1, which is find the GCF for the numerator and denominator. Now, before we move on to the next step, I want to point out that there's another way we could have found that GCF, and I think it's an easier way, and it's by using prime factorization for both 4 and 6. So you could put 4 and 6 over here. They both sprout roots. You pick any 2 numbers that can be multiplied together to equal 4, so 2 and 2, because you can't pick 1 times 4. And then 2 times 3 is 6. And these are all prime numbers. Then, however many times each of these prime factorization trees have the same number in common, we write that number once. So we have 2 here and 2 here. So we put 2 here. Now we have a 2 over here, but nothing to match it over here. And we have a 3 over here, but nothing to match it over here. So that means the greatest common factor is 2. Same thing we found when we did it this way. Okay. Now step 2 is divide the numerator and denominator by the GCF, by the greatest common factor. Divide the numerator and denominator by the greatest common factor. So we divide 4 by 2 and we divide 6 by 2. We'll put the answer right here. 4 divided by 2 is 2. 6 divided by 2 is 3. So 4/6 written in simplest form is 3. Let's do another example together. Let's make this one a little bit harder. Let's do 12 over 22. Let's put that in simplest form. So the first step is we find the GCF for the numerator and denominator. And we can do that in two ways. We can either list all the factors for 12 and 22, and then circle the biggest one that's in both lists, or we can use prime factorization. I like to use prime factorization more, so we'll do it that way. Okay, so both numbers sprout roots, and we pick any two numbers that can be multiplied together to equal 12. That's 2 times 6, or you could pick 3 times 4. You just can't pick 1 times 12. 2 is already prime, 6 isn't. 2 times 3 is 6. Okay, 22, we can do 2 times 11, and those are both prime. Now we see where the two prime factorization trees have numbers in common. We have a 2 here and a 2 here, so we put a 2 here. Now we have a 2 here, but nothing to match it over here, a 3 here, but nothing to match it over here, an 11 here, but nothing to match it over here, which means 2 is the greatest common factor. So step 1 was find the GCF for the numerator and denominator. Step 2 is divide the numerator and denominator by the GCF. So we're going to divide 12 and 22 by 2. "12 divided by 2 is 6. 22 divided by 2 is 11. So 12 over 22, written in simplest form or reduced to simplest form, is 6 over 11, 6/11. Now, how do we know that 6/11 is in simplest form? How do we know that 2/3 is in simplest form? You know a fraction is in simplest form when the greatest common factor for the numerator and denominator is 1. So if we list all the factors of 6, we get 1, 2, 3, and 6. And if we list all the factors of 11, it's prime, so we just get 1 and 11. What's the biggest number that's in both lists? It's 1. That's how we know 6/11 is in simplest form. If we list all the factors for 2 and 3, for 2, it's just 1 and 2 because 2 is prime. For 3, it's just 1 and 3 because 3 is prime. What's the greatest common factor in both lists? The biggest number that's in both lists? It's 1. That's how you know 2/3 is in simplest form, when the greatest common factor for the numerator and denominator is 1. Let's do another example together. And you can't see these steps anymore, the 2 steps, because I have to scroll down, but hopefully you wrote them down in your own math notebook so you can see them there. Okay, let's do another one. Let's do 2/12. So step 1 is find the GCF, or the greatest common factor. So we're going to do prime factorization. Let's put a line like this so we don't get mixed up, so we know we're doing something different. So both numbers sprout roots. Is there anything we can multiply by 2 to equal 2? Nothing, because 2 is already a prime number, so we can't do prime factorization for 2. But we can for 12. 2 times 6 is 12. 2 is already prime. And 2 times 3 is 6. 2 and 3 are prime. Now, wherever there's a number in both lists, we put it down here. So we have a 2 here and a 2 here. So we put 1, 2 here. There's nothing else in common because this only has one number. So the greatest common factor is 2. And the second step is we divide the numerator and denominator by 2. So 2 divided by 2 is 1, and 12 divided by 2 is 6. So 2/12 written in simplest form is 1/6. I'm going to turn this paper over now because it's getting a little crowded, and we'll do some more examples together. Let's say we had the fraction 6/8, and we needed to put that in simplest form. Okay, You can use prime factorization to find the greatest common factor for 6 and 8. So you could do 2 times 3 to equal 6, and those are both prime. You can do 2 times 4 to equal 8. 2 is prime, and 2 times 2 equals 12. Now we have a 2 over here and a 2 over here, so we put 1, 2 here. We have a 3 here, but nothing to match it over here. 2 more 2's over here, but nothing to match them over here. So the greatest common factor is 2. Second step is we divide the numerator and denominator by the greatest common factor, by 2. And 6 divided by 2 is 3. 8 divided by 2 is 4. Let's do another one. Let's do 2/5. Let's see what happens if we try to put 2/5 in simplest form. So we try to do prime factorization for 2 and 5. What can we multiply together to equal 2? Just 1 and 2, because 2 is prime, so we can't do prime factorization for it. What can we multiply together to equal 5? Just 1 and 5, because 5 is a prime number, so we can't do prime factorization for 5. Which means the greatest common factor for 2 and 5 will be 1. See, all the factors of 2 are 1 and 2. All the factors of 5 are 1 and 5, because 1 times 2 equals 2, 1 times 5 equals 5. Nothing else can be multiplied together to equal 2. Nothing else can be multiplied together to equal 5, except 1 times 5. So that means the greatest common factor is 1. And when the greatest common factor is 1, the fraction's already in simplest form. So you can't put 2/5 in simplest form because it already is in simplest form. Let's do another one. Let's do 6/10. Okay. Now, you can do prime factorization, or you can list all the factors. When it's small numbers like this, it's actually pretty easy to list all the factors. So let's do it that way this time. The factors of 6 are 1, 2, 3, and 6, because 1 times 6 is 6, and 2 times 3 is 6. The factors of 10 are 1, 2, 5, and 10, because 1 times 10 is 10, and 2 times 5 is 10. These are the only numbers you can multiply together to get 10, and these are the only numbers you can multiply together to get 6. Now we look for the biggest number that's in both lists, and that's 2. 2 is the biggest number that's in this list and this list. We found the GCF, the greatest common factor. Now the next step is to divide the numerator and denominator by that greatest common factor. We'll put the answer over here. 6 divided by 2 is 3. 10 divided by 2 is 5. So 6/10 written in simplest form is 3/5. Let's do another one. Let's do 4/16. Let's do this one this way too. Okay, the factors of 4 are just 1, 2, and 4. The factors of 6 are all the numbers you can multiply together to equal 6. So that's 1. Not 6, 16. The factors of 16 are all the numbers you can multiply together to equal 16. So that's 1 and 16, because 1 times 16 is 16. That's 2 times 8, because 2 times 8 is 16. And 4, because 4 times 4 is 16. There's no other factors of 16. And if you have a hard time doing it this way, you should do it this way with prime factorization. 2 times 2 is 4. 2 times 8 is 16. 2 and 2 are both prime. 2 is prime. 8 is not. 2 times 4 is 8. 2 is prime. 4 is not. 2 times 2 is 4. Now we write however many times one number repeats in both lists, we write that number down here. So we have a 2 here and a 2 here, so we put a 2 here. We have a 2 here and a 2 here, so we put a 2 here. There's no other numbers in both lists, And so we multiply those two 2's together. 2 times 2 equals 4. So that's the greatest common factor. And that's what we find here too. The biggest number in both lists is 4. So we found the GCF, the greatest common factor, it's 4. And now we divide the numerator and denominator by the GCF, by 4. So we divide 4 by 4, and we divide 16 by 4. 4 divided by 4 equals 1, and 16 divided by 4 equals 4. So 16/4 in simplest form, I'm sorry, I said that totally wrong. 4/16, I can talk right, 4/16 in simplest form is 1/4. Okay? Should we do one more together? Let's do one more. 12 over 24. Okay. Now, you can either list all the factors or you can use prime factorization. I think when the numbers are big, like 24 is kind of a big number, I think it's easier to use prime factorization. So let's do it that way. They both sprout branches. We pick any two numbers that can be multiplied together to equal 12. We can use 3 times 4. 3 is already prime, 4 is not. 2 times 2 is 4. You pick any two numbers that can be multiplied together to equal 24. You could use 3 times 8, 4 times 6, or 2 times 12. Let's do 4 times 6. 4 is not prime. 2 times 2 is 4. 6 is not prime. 2 times 3 is 6. Now these are all prime. We have a 3 here and a 3 here, so we put a 3 here. We have a 2 here and a 2 here, so we put a 2 here. We have a 2 here and a 2 here, so we put a 2 here. Now, there's a 2 here, but nothing to match it over here. So we multiply 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. So the greatest common factor between 12 and 24 is 12. So now we divide the numerator and denominator by the greatest common factor, by 12. 12 divided by 12 is 1, and 24 divided by 12 is 2. So 12 over 24 in simplest form is 1/2. And you can tell some of these you can simplify in your head, because if you know that 12 is half of 24, you already know it's going to simplify to 1/2. Anytime the numerator is exactly half of the denominator, it's going to simplify to 1/2. Okay, I will give you some independent work now. I'll just assign 2 for independent work. Let's see, I'll give you a hard one, 12 over 40, 12 40ths, and then I'll give you an easier one. How about 9 12ths? Okay, simplify 12 40ths and simplify 9 12ths. Try your best to do it independently, and then click on the video attached underneath this one to see if you did it correctly, and I will see you there.